right, microphone time. All right, welcome to Shiny Let's Be Bad Guys. This is a tutorial about exploiting and mitigating the top 10 web application vulnerabilities. We're going to be talking about Django and Flask in particular to try to address some of the more popular Python frameworks. Before we get going, we have a couple of quick announcements we want to make sure we get through. So today's session is going to run from 9 a.m. to 12:20 p.m., at which point lunch. We're going to have a 20-minute break about 10:15. There should be coffee and refreshments and something outside. And then when it's lunchtime, that's going to be in room 710. That's upstairs. Watch for all the other PyCon people going upstairs, I guess, is the way to find that. I haven't been up there yet. Tutorial feedback this year is submitted via the Guidebook app. So go into Guidebook, look for the tutorial survey link in the talk details, and please be honest, it is a huge way to help the program committee and the tutorial committee shape what the tutorials are going to be like in the future. So I know that some of the feedback from last year helped us have less crowded rooms this year, so definitely a worthwhile thing to do. There are also tons of opportunities to make PyCon a very personal and rewarding part of your stay here with us over the next few days by volunteering. Volunteering is low commitment and a lot of fun. It's a great way to meet a ton of people, make new friends. Some of the things that are really important are the swag bag stuffing. That's going to be Thursday from 3 to 6. It's an amazing process if you've ever seen it or not seen it. Trying to get nearly like 1 million pieces of stuff stuffed into bags for everybody is pretty intense and pretty crazy. But even if you stop by and do like 20 or 30 minutes, it's a huge, huge help with that. The registration desk can use volunteers at any time, and it's a wonderful way to get to know people. And there's a bunch of other opportunities as well. You can go out to us.pycon.org/2015/about/volunteers or find the volunteers link in, I think it's the About menu. Yeah. So anyway, go out there. You can see what volunteer opportunities are available. It's a really fun way to give back to PyCon and help make it a wonderful event for everybody. So like I said, this is Shiny Let's Be Bad Guys. My name is Mike Pirnat. I am an advisory engineer at American Greetings, and one of the fun things that I've gotten to do over the past few years is put together this kind of training about the OWASP top 10 so that we can maintain PCI compliance and try to defend our sites against ne'er-do-wells. And my companion today is David Stanek.
I'm David Stanek. I work at Rackspace as a software engineer. I spend my days now doing open source stuff in Python, and it's kind of somewhat a security focus. I work on Keystone, which is an authorization system for OpenStack. So a lot of this stuff, if we have the problems, there's a bigger problem within a cloud. So this stuff is extremely important to me.
All right, and as some of you probably could have guessed from the title of this presentation, I still have feelings about Firefly. I should get over them, but So who out here in the audience makes web applications? All right. Who out here in the audience has vulnerable web applications? Some brave souls who don't. Very good. So why is this important? So this is really important to protect, obviously, your users from identity theft, from financial harm, from all kinds of terrible hacks that have been going on over the past few years. It matters because your data is important to you, right? And you don't want it stolen, screwed up, tampered with, damaged in some way. And it can be business critical, right? So this can mean the difference between life and death depending on your level of funding, right? So the cost of like a credit card breach is ridiculous. It can come with all the identity theft protection that goes with it. It can come to about $200 per compromised credit card record. So $200 times like, hey, I've scaled up my startup to 1 million people, like that could be a serious game over moment for you and not a lot of fun. So we need to protect our business as well as ourselves and our users. So OWASP is a group that is a nonprofit that's focused on improving software security, and they produce documentation and tools that help teach people about security and help to protect your applications. And you can find out about them at owasp.org. They publish a thing called the OWASP Top 10, and that's what we'll be working through today. So this is based on risk data from a number of firms with over 500,000 vulnerabilities cataloged from hundreds of organizations and thousands of apps. They select and prioritize these vulnerabilities based on how prevalent they are, combined with estimates of how easy it is to exploit them, detect them, and the kind of impact they can have on you. This gets updated every couple of years. It was last updated in 2013. You can find it out at owasp.org. Don't worry about writing down tons of URLs throughout this. The slides are already online. There's a link to the slides in the repository README, so that's out there already for you, but we'll be referring to things throughout. So today, we're going to talk through each of the top 10. We're going to present some background on each type of vulnerability. Then together in class, we'll time box a little activity where we exploit it in a little trivial toy application that we've made. And then we'll talk about prevention strategies, both in general and then specific to Django and Flask where that's possible. And we'll have some light example code where there's time, but there's a lot of material, so it's more about understanding how to do the exploit and then talking about mitigation at a high level with additional reading for you to do later on to explore that stuff. So, the inevitable disclaimer. What you do with this knowledge that you learned today is up to you, and neither Dave nor I nor the PyCon is responsible for how you use this. A lot of what we talk about in here is actually a criminal act if you do it to a site without permission. So please use this only for good and not for evil. Django in general has a really good security stance. We're not trying to pick on it. It was just an easy thing to make the exercises in. You get a lot of protection out of the box, and they're basically techniques to mitigate everything that are either out of the box or not too hard to enable or add. We're not really trying to pick on it. Like I said, we're trying to hold it up as a positive example. But definitely go read the security in Django documentation because they do a really good job of that.
Just to add on to that, Django, basically a lot of these things are done for you in Django. Like I had to go out of my way to figure out how to turn things off and get around some of their built-in security. So we're definitely not picking on Django. They do a really good job at this. It's just a lot of it is still up on the developer using the technology to do it correctly.
Yeah, Flask, unfortunately, is a little bit DIY. There's a lot of options for mitigating things. There's a lot of strategies out there, but there are a lot of alternatives too. You'll find like 3 or 4 or 5 plugins that all do similar kinds of things, and we'll see that as we go through today. But unfortunately, a lot of it is not out of the box. Setup instructions, I think everybody's set up at this point. Raise a hand, anybody who's not, just so we can. All right. Well, you're going to buddy up? Excellent. So we're going to gloss through this to my favorite setup instruction, which is find a partner. It's another great way to make friends at PyCon. All right, so number 1, the first, excellent. So our first vulnerability we're going to talk about, the most prevalent, is injection, and it comes in several flavors. And do you want to talk about injection this morning? All right, cool.
Okay, so injection is a really simple one to understand because it's just taking external data and somehow getting it into your system. Right? It's data from a user or from somebody else. It's untrusted. It's not something that you're specifically trying to submit to yourself. And the biggest problems is it could cause data corruption, denial of service, and it could open up to a lot of other attacks. A lot of these attacks you'll see could be chained together to actually make a bigger breach. So you'll use this to inject something to get access to something else, and then once you get access to that something else, you have maybe a shell in the box, and you can do as much as you want. And that complete host takeover is probably the scariest thing, but as long as you're doing some of the mitigation techniques, you'll be okay.
So question. So who can you trust? Anybody? Who can you trust? It is a trick question. Trust no one.
All right, so there's a lot of different types of users. None of them should be trusted. Like nobody out there should be trusted because people could accidentally do things And that's another attack later on, but they can accidentally do things even if they are well-meaning users. So there's a lot of ways to get data into your system, some of which you know, get and post parameters, that's obvious, query strings. But path info is a really big one because people use regexes to parse path info, and then they expect it to be safe, and they do things with it. And that's the actual path part of the URL. Headers like cookies and hosts, a lot of people just assume that the browser is going to send me a great host header, and I'm going to parse that, and I'm going to do something with it. But that's not always the case because malicious users can control that using curl or whatever other tools that they're using. And uploaded files you can never trust. You can never execute or do anything with them besides redisplay them back to the user because there's a lot of things that they could do. Oops. Okay, so a lot of different consequences, right? You can actually inject things into queries that people are running against their database. So you can imagine a case where you find an error message that says part of a query or gives you some kind of hint what to do, and then you basically just dump all the users to the screen. So now you have the user table, or you delete some other table that they have, or you could do all kinds of really bad things. Private files on disk, like your Etsy password or other things, if you're bad and you're running your web server as a user that has access to those things, and then you give them a way to navigate to the files, they have access to all that stuff. And then the worst thing imaginable is someone just executes whatever code that they want on your box. They're able to upload Python code. They're able to find a flaw in your website where they can go to a URL and have it executed. And basically whatever they want to do, they can do at that point. So these are a lot of the real world examples. PlayStation, Ruby on Rails. There is some stuff from eBay.
PlayStation was SQL injection. And there was, what, like 70 million records compromised? Like
probably some of you guys have been compromised because of that. Rails had a big one. Was it like 3 years ago?
Yeah. Something
like that. ESPN one, this is mine. This is just an example that I gave a long time ago. The URL doesn't work anymore.
They broke that since last year, I think.
Yeah, so basically they were showing an error message on the screen that was basically directly from the query string. So I was able to just format my own query string to give myself a fantasy football profile on ESPN's site, and it looked real. And then I used Bitly to make a short link, and to my surprise, it gave me an es.pn link, so it looked official. So I was able to send this out on Twitter, and it gave me a really great profile on ESPN's site. So there's a lot of things like that. That was fun and games, and it was just something I saw that I could do. But you can imagine something very, very bad happening because of that. Yeah, so this is the first exercise, the SQL injection. So you can see the query here where we're doing a select star from users, and there's a %s where we're expecting to just put something in. And so if you're able to craft what data goes into that, and you're not going to, and the developer's not filtering it, you can actually terminate this query and execute another query. So if you navigate to this URL on your browser, or you click the link on that first page, you'll get to the first exercise. And it'll have a little bit of instructions and a little bit of help as you go through and try to experiment with it. And there's also a button at the end that says, show me the solution. But don't click that right away. Try to experiment a little bit and see if you can actually get it before you ask for help.
There's also a solutions file in the repo that is the cheat sheet if you need it later or you want it later.
Yes, don't use that right now.
Yeah, that ruins the fun. So we'll take about 5 or 6 minutes and time box this and walk through it, and then we'll do the solution at the end of that. Sound good?
We'll come around
and yeah, we'll circulate around and be glad to help. So wave or shout or let us know. So this is one of my favorite XKCDs of all time. If anybody's an XKCD fan, yeah, little Bobby tables. There's a question about why are we ending with a comment? And the answer is that you still have some additional SQL statement that you want to throw out, that you want the database to ignore when it's processing it. Yeah, you want it to run, you want it to start running the original, stop, but then you still have stuff left over, right? So you're going to be injecting into where this %s is, and then there's still this extra stuff on the end that you'd like to get rid of. Right, because there might be additional, yeah, you might end up with a syntax error, and Oracle gets cranky about it or something, and then you don't get the data you want. You get a database error, and then it shows up in somebody's monitoring, and they say, oh, somebody's trying to do bad things to me. Yeah, you want to be undetected.
Until you drop the table.
Yes. All right, everybody just about there? Anybody else? I think we can. Anybody want to see the solution? All right. Dave wants to see the solution. All right, we can do that. So let's get started. SQL injection. Blah, blah, blah. No, that's no good. So here, we're going to end that that %s that has, we're going to end the quote, finish the existing statement that was going on. We'll drop the users, and then we use this comment at the end. Let's go ahead and do that. And if I submit that, then that ends up making this query. So we're doing the select gets terminated, and then we drop the table. Goodbye, and you don't have any more users. Ha ha ha. Any questions about that one? Nice little warm up, get you thinking like a bad person today. All right. So another thing that we talked about was the possibility that you might access private files. So if you've got file system access and you've got unvalidated user input, you might allow attackers to navigate your file system and go find something that you want. In this case, if you go on to the next exercise, we are going to steal the settings.py from our Django app. And we'll time box this one to about 5 minutes. It's not too bad. question was.
So the question was, both Flask and Django would probably protect you against this one. And the answer is no, because this is typically a programmer doing something with the framework. So they don't usually give you facilities to just show a file or whatever. You're actually writing the code to do that and display it somehow.
This is bad business logic.
Yeah, so you're like writing a Flickr site or whatever, and you're going to store them on disk or some other persistent storage, and you're going to find them based on some mapping somewhere. And if you do it incorrectly and use the file path that the user gives you as like a token or something, then you can do stuff like this.
Yeah, so our time with this thing, should we walk through how this works?
Yep.
Okay, so, oh, here we've got hacker JPEG. I wonder what happens. So all right, we've got that hacker JPEG, so let's try to get settings. Oh, no, that isn't it, but I bet if we start navigating up the file system, there we go.
So at that point, you're really just trying to find it in the file system. So that's one of the other reasons that people tell you to turn off a lot of debug mode that gives you like the traceback, because that shows the attacker a file system and it gives them a starting point to find this kind of stuff.
Yeah, so what kind of fun stuff is in here? Oh, there's whatever stuff you've got enabled, like your apps. Where's the secret? Ah, yeah, there's your secret key. Don't share this with anybody. Especially not evil hacker people, right? Okay. Actually, I still want to be here. Let's go and close that. All right, you want to intro the next one?
So this is the scary one. This is where you're actually going to be crafting your own code, and you're going to run it on the server. So you can imagine, having an input box where you're going to somehow craft some Python code and submit it to the server in a way that it's going to actually execute it. So this is a little bit harder, but if you go into the exercise, you'll see it gives you a little bit of instruction on the one-liner and stuff like that and what to do. You'll have to dig into a probably interactive Python interpreter to actually execute the code and encode it as the instructions say. So don't worry if you're doing that, because you're doing the right thing.
Yeah, and since this one is a little more involved, I think we'll time box it at like 8 or 9 minutes and see how people are doing. This one, I think we usually end up going a little longer just in case. So we'll start there and see how everybody's doing, all right? A resounding silence. But again, if you do have questions, please don't be shy. This is a good one to get advice on. It's fine. There's no shame in it. None at all. Yeah. All right, Dave. So that's 10 minutes. Do we want to go a little longer? Well, I think a lot of people I've seen have got it. Should we ready to roll the solution? All right, everybody ready to see how this works? Okay, so I was trying it. I didn't do it right. So what we're going to do is go into an interactive Python session. If you're on Python 3, it's a little different because of how base64 works with bytes instead of with strings as a switch from 2 to 3. But basically, we're going to make some Python code in a string. We're going to open our pwned.txt in write mode, and we'll tell it to write the file or write some data into it. And then we take this whole thing and base64 encode string it. And then copy and paste that value into our text box here. So that gets us this nasty looking garbage. And if we submit that, yay, we wrote a file that says boom. And just to prove that we've done that, let's even take a look in the terminal. Let me pull this over here. Yeah, so we just wrote pwn.txt. And let's rerun the server. Yeah.
So there's a couple of questions about the base64, why that was done. So generally speaking, if you look at hidden inputs on forms, you'll see that a lot of sites use them to kind of carry data from place to place, right? So maybe something similar to what you would put in a cookie maybe, but for whatever reason it's in the form. And when you look at the hidden input, it's often really easy to see the data as base64 just because the format's easy to recognize. So you would take that hidden input, the data from the input, you'd put in interactive Python, decode it and play with it, try to figure out what it was. In this case, in our fake site, I found that it was Python code. So
like a dictionary.
Yeah. So what other stuff could I put in there to attack the system? So you could look at any, and that's not illegal to do, right? You can actually open up the source code for any page, look at the hidden inputs, look at, compare what goes in the query string to what is in the page, because a lot of times people just take it directly and stick it into the page, and then you could basically figure out what they're using from doing those simple things.
But as you said, this could be a cookie that's base64 encoded as well, right? You could be preserving state there, and if you say, oh look, this is a Python dictionary that's been encoded, there's another potential place to look at for something like this. So it doesn't just have to be like a form input, but basically like places where some state has been serialized out, and if you do it naively, it could just be like, oh, I've stringed this thing out and base64'd it, and then I'm going to eval it back in because that makes Python objects. Hooray!
And so, I mean, the reason this isn't hidden input is because I wanted to be able to attack it through the site, as opposed to having to craft like a curl request or doing something other using a manual tool. Do you have another question?
Yeah. So I was wondering, so for most, so it's not everything that stores state you can use to craft, right? So like a lot of, so it's like, because for example, like Django has the CSR open.
Yep.
Wouldn't be eval or.
Yeah. So the question was, not everything that is in here would actually be exact or evaled. And so that's the case. Typically speaking, you should never do that. Like no web app should ever take data from anywhere and exact or eval it. Even if you think you own that data and that you control that data, there's a chance that in the future that might not be the case.
Yeah, if it's been to the client, you don't own the data anymore.
Or if another developer comes 2 years later and doesn't understand why that data is there and what it means, and they get data from the user later. I mean, you just never want to do that. There's almost no reason to do that.
But what is the recommended way of retrieving, say, a dictionary?
So this is the kind of thing you might see where like somebody didn't have a robust session infrastructure. You want to anything that you're wanting to do to preserve state from like page to page should probably be in a session. So like Django has a session stuff built in. Flask has session stuff that you can plug in. This is really kind of like I put too much trust in stuff that went on at the client side that's going to get played back to me, and that's not what you want to do.
I can't remember where in the standard library it is off the top of my head right now, but there is a safe eval. I think it's like in the AST module.
Yeah. It's in the AST. There's an AST safe eval that will actually, it's called literal eval. Yeah, so it will only make Python literals. It won't actually exec any code that like eval would do along the way. All right, so should we?
Yep. Flip it. So I mean, how many people thought that this was really simple once they did the exercises? Like how trivial it is to do this. See a lot of heads nodding. So I mean, it's really scary because this is number one. So this is like the thing that people typically attack and has the most value, and it's probably one of the easiest to do. And so, you know, why is that the case? Well, typically people aren't validating properly or at all. Or they validate on the client side because it's really cool to do the JavaScript framework thing and not care about what happens on the server side. And all the data that you're sending out, if you are going to do something with it or trust it in any way, do something like signing or some kind of crypto on it or something to make sure that the data that you expect to be there is the data that you get back. So the user can't tamper with it in any way, even accidentally.
You may even, if you're really crazy, want to sign that with a key that's specific to that user so that if it gets broken in some way, it's still not going to affect other people. If you're talking to the database, oh, sorry, question. Right, don't do that. Yeah, don't change cookies on the client side if you're going to trust them later. Yeah, that's bad news. Yeah, and in general, a lot of the advice now is to start having your cookies not even accessible to JavaScript. There's an HTTP only flag that you can set on the cookie, and I think we'll talk about that a little later on. But yeah, you can set a flag on the cookie so that the JavaScript interpreter won't even see it. It won't even be in document.cookie. So like for a session token, like there's no reason that JavaScript needs to see that or mess with it. If you're talking to the database, use an ORM or make sure to bind the variables that you're passing in when you're talking to it. That binding will help to prevent the injection attacks, or your ORM will escape things properly to get around that. And like we said, don't use eval or exec. You need in Python to be aware of or be scared of using pickle, and don't use user-supplied YAML. That was Rails' problem a couple years ago, and a lot of Rails people had like really bad day. They had a vulnerability in the YAML interpreter that would exec arbitrary code. It was no good. So for Django specifically, you really need to make sure that the data types for your model are tight, and this really goes for Flask as well. Anywhere you're modeling your data, make sure it's only allowing the things that you're going to want to have in the database. We recommend using Django forms instead of model forms for stronger validation. And do you want to talk about that? Because I think this is one of the... Yeah, you can.
I mean, one of the big things that you want to do is every time you get the data in, you want to be as precise as possible about what you expect. And I find using forms gives you a lot more control than model forms. Model forms basically auto-generate stuff for you and do some of the validation for you. But if you go out and you make your own forms, you can do a lot more detailed analysis of the data coming in. Because you want to make sure that if it's an integer, it's an integer. And if it's an email address, that it's an email address. And maybe even more specific than that, you only want email addresses from a certain set of domains or certain types of data coming in. You want to make sure that that stuff is as tight as possible.
Yeah, I think one of the reasons that we like forms over model forms is that if somebody comes along later and adds a new field to the model or adds a new attribute to the model form by default is going to surface that. And that might not be something you want exposed out to the world and accessible to the world. So in a form, you're explicitly saying what things are going to be in this form, whereas a model form, you have to like know to say, no, not this one, and no, not that one, and no, not this other one. And so it's a little easier to screw that up. Make new validators as needed for your application. Make them relevant to the type of business data that you have. So instead of an integer, maybe it's a user ID or a product number that has specific rules on it. You can tighten things down and, like Dave said, make them very specific to the kind of data you're going to have. Yeah, give them semantic meaning. Yes, exactly. And make sure your URL regular expressions are really tight for dynamic URLs, so that you don't have somebody coming and messing with the path of your data and getting you into trouble, right? So you want to make sure that, like with the navigating the file system, right? You don't want to be able to have dots and slashes and all kinds of stuff in there. So maybe the regular expression needs to be a little tighter on that. So for Django, also use the ORM when you can. If you can't, use extreme caution. You want to do variable binding, and never ever concatenate string, use string concatenation or string formatting with anything that came from the client. So if you don't get to use the ORM for something because your query is really difficult, you want to make sure that you're passing that params in. That gets you a dictionary of the bind variables, and the ORM will know how to fill that stuff in appropriately. Or if it's more complicated, when you're doing a cursor execute call, you'll want to make sure you pass that list of bind variables, and the cursor will end up, the execute call will end up formatting it correctly. For Flask, I think their recommendation is to use the Flask WTF, to use the WT forms library. I also like to use SQL Alchemy for talking to the database, because SQL Alchemy gets around a lot of that same stuff, just like the Django ORM does. And again, use bind variables if your query is going to be really complicated. Any questions about that? All right, cool. We are done with number 1. All right. 9 more to go. They're faster, though. Do you want to start talking about this one, or do you want me to get on with it? All right. Okay, so number 2 is broken authentication and session management. So this is where an attacker uses leaks or flaws in the way that your app authenticates or manages sessions to impersonate some other user. And the big cause of this is people implementing roll your own solutions and just doing it because, oh, this is easy now. I can do this really easily. And because also it's harder to detect these because of these roll your own solutions. You don't know that you're vulnerable to it in the same way that you would if you used an external library or a contributed library that's part of the framework that could then have a security announcement for it, right? There's no security announcements for the code that you write yourself. Wouldn't that be nice? So things that could go wrong when you've got this going on. You can compromise user accounts. Worse, you could compromise administrative accounts. And that can lead to unauthorized use of some kind of privileged functionality. So we don't actually have any exercises for this that were meaningful, so we'll just talk through the prevention. So you want to hash or encrypt your passwords. You want to do it better than Adobe did it. That was a bummer. I didn't like that day. You don't want to let these credentials be overwritten easily. So you don't want to make it too easy for someone to say, like, hey, I need to reset my password and, blast that in or whatever. You don't want to put session IDs in URLs. That's bad news. I wince every time I see that on a website. You want to allow session IDs to time out, and you also, and this is maybe like, sounds really dumb, but you want to make sure that users have a logout button that they can log out with. That's a really easy thing to forget when you're trying to throw together an application really quickly. It's not like a sexy thing that your business owner is really excited about, like, oh, that logout button, right? But needs to be there. And then after a successful login, you want to make sure that the session ID rotates so that you get a new one with each login, so that the old session is gone, it can't be used anymore. You don't want to leave that data hanging around for somebody else to get at. And anytime that you are passing passwords over the wire or session IDs, you want to use TLS, or what people would say SSL, but it's TLS now. You want to have a secure encrypted connection for all of that, authentication tokens flying over the wire. So for Django, Django contrib auth is really great. It provides login, logout, registration, password recovery. It's very easy to customize. You can customize all the emails and web pages and stuff to make it look and feel exactly like your site does. It's really easy to customize, which is great, but it's way too big for us to dive into today. So it's a great, like, you should go learn all about it. You may also want to consider the Django session security middleware for timing out sessions. So that provides JavaScript and Ajax gateway to doing the session timeouts. It's pretty easy to set up. So it uses, the JavaScript looks at clicks and scroll activities and key press activities to ping back to the server to keep your session alive. So that's a nice activity-based way to do that. And we'll talk about the transport layer security stuff a little later on. Flask, definitely worth looking at Flask security, which bundles together a whole bunch of different sub-projects. And this can solve and address a lot of these problems. They provide login, logout, registration, password recovery, all that good stuff, as well as a roles framework and permissions framework similar to what Django has. You definitely want to avoid the overuse of cookies for storing your session state, because it's real easy to mess with that if you're a bad person. So don't load up on cookies. Cookies are sometimes food. All right, yeah, any questions? Yeah, so the question was, can we talk about the dangers of showing off your session ID? Do you want to take that one, or do you want me to do it?
So I mean, there's a lot of different reasons why you might not want to do that. So like the most obvious one is that if it's there and it's in a browser, I can capture it and try to replay it later. Especially if you're, like what Mike said earlier, if you don't time out your sessions, then that session ID is still valid for some period of time. If you go to a public computer, or I just see your laptop sitting out and I just copy that session ID, I could actually log into that site or do some action as you.
Or if somebody's at the Starbucks with you and they've got Firesheep running, and they can watch all the traffic flying across the Starbucks Wi-Fi or the Panera Wi-Fi or what, or the, not that it would ever happen here, but PyCon Wi-Fi, right? This is why I always have, like, anytime I go to a conference or I use public Wi-Fi, I have a encrypted VPN session so that nobody sees, like, what the traffic is or where it's going. It's real easy, whether it's in a cookie or it's in the URL. It's real easy to steal those session IDs out. Like Facebook had a problem with this a couple of years ago, and they've since really locked down as a result of it, which is good, right? But it used to be really, really easy to just like go to a Starbucks and like, poof, now I can be 10 different people on Facebook. And then think about the harm that you could then do if you have, like, if you get to be somebody else on Facebook, like what kind of stuff could you get at? And what kind of information could you gain? How could you leverage that? There's a lot of avenues for further evil. Yeah. Right. So if you use TLS, you are in good shape if it's a cookie, because that's going to be not so much in the clear, but the URLs could still be intercepted, right? So if you have a session ID that's like in a query string parameter or in the URL, that stuff can still be intercepted or man in the middle along the way very easily. Right, because it's going to get written into log files of every device that's in between you and where it's going.
Or even more low tech. I can stand behind, if you're on your bank site and I see the J session ID, I can just take my camera out real quick and take a quick picture. It takes me 2 seconds, you wouldn't even know what happened. And now, immediately after that, I would walk away, grab my laptop, and I would log into your bank as you. Right, so there's a lot of ways to do it, like Firesheep and doing some of the more technical things, but there's also really low-tech ways, like I could just over the shoulder and, all of a sudden you're compromised. I can transfer all your money out. Is
that answer your question? Awesome. Anybody else? All right, where are we at time-wise? We got about 15 minutes before the before the refreshment break. So let's dive into this one real quick then. Yes. All right, do you want to do it? Or? Sure. All right.
Cross-site scripting, this is one of my favorite ones. So it's shortened by XSS. You'll see this all over the place. It is significant. It's everywhere. And this is one of those ones like injection that you'll see, are the most common attacks because they're very easy to do from the outside. Effectively, it is basically similar to injection in that you're injecting some data out into someone's web app, but you're normally do it across sites. So you're expecting data in, you're getting data in that you expect, but you're tricking the user into submitting that data. So,
3 types.
So stored, right? So this is like probably the one that people think is not possible. The data gets somehow into the database or into like a forum session. I think this was there's an example of a site that had a problem where someone could post something on Facebook that was an image, and it would log you out of was it Facebook?
Yeah, it was.
Oh, that's right.
Yeah, it was really cool. So there was a point where you could post an image link on Facebook on somebody. You could write on somebody's wall like, "Here's this image. It's awesome." And what that image would do is it was actually the logout URL. So anytime you logged into Facebook and went to your wall, you would get logged out of Facebook immediately. And until that fell off of your wall, you were DOS'd from Facebook. It was pretty cool. They fixed that though, thankfully.
So you can imagine that being a problem. Reflected, so this is basically code in the request. And this is what I did in the ESPN hack, is that there was something in the error message that was basically put back into the site, and they didn't sanitize that data because they assumed that we're the only person putting in error equals whatever in the query string. And it turns out that anybody could do that. So you need to sanitize at that level coming in. And then injecting code into the actual DOM of the browser. So this is a little more complicated. This is more like adding a query string value, very similar to reflecting that the data is probably going to be put into the page and executed by the browser, but it's going to actually manipulate the actual browser DOM, right? So it's going to change the elements and make them do things that the initial developer didn't expect it to happen. So, I mean, all these things kind of have the same kinds of consequences. This has a couple extra ones in that you can actually very easily deface sites. So hijacking sessions we saw in the first two, essentially. Executing scripts happens through most of these things. But defacing sites, going through and doing hostile content, so like taking over someone else's site and doing it in a way that the actual site owner doesn't know it's even happening is one of the side effects of this. So like, I give you a link, it's custom crafted to have JavaScript in it that executes and breaks things or changes the way it looks. Well, the site owner never sees that happen. You get that coming in, and it changes your view of the site. Maybe it changes like input boxes to post your password to a different site. Or
could drop malware on you, right? So like if like an ad server 6 layers down gets compromised, like, right, and drops something on you, that's a great way to do that too.
I mean, redirecting users is a kind of a silly one, but it's extremely powerful in that you give someone a link to Facebook, they see facebook.com, and say Facebook had this problem, right? You would give them a link to facebook.com and it immediately redirect them down to dstanek blah, 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 something, something / Facebook. So it looks official, looks exactly like Facebook, except I'm capturing all the passwords. And maybe I'll capture them and then log you into the real site and then send you over there so you don't know anything happened. But in that meantime, I just basically man in the middle of you and took whatever I wanted. You'll see a lot of places where it's easy to actually put in your own data, unfiltered data. So places allow you to put in links. Some places allow you to put in script tags and do like fancy things inside of comments. Very, very dangerous. Inputs and script tags that are basically completely unfiltered and allow you to insert data in. It makes it extremely easy to just custom craft that code so that it fits in the same way we did the SQL injection earlier, where we basically end the existing code, what was expected, put our code inside of that, and kind of comment off what's after that. Allows you to do that inside of form fields and script tags.
All right, so we will try to get an exercise in right before the break here. We've got a couple of them. We'll come back to cross-site scripting after some coffee. But so the first part of this is cross-site scripting using a dynamic URL. So this is where part of the URL path is variable but isn't validated, and some piece of it gets included into the page. So like a canonical example might be you're navigating the catalog of some e-commerce site, and you have a URL that has the category in there. So it's, localhost or example.com slash categories slash shoes slash computers slash whatever, and that shoes or computers or whatever gets taken out of the URL and used to drive what you're looking at on the site and what you're looking at on the page, and maybe is included back into the page, like your category is computers, your category is shoes. So in this exercise, we've got something like that, where a piece of the URL is going to actually end up being included in the page. So we'll go ahead and get started. We'll time box it to about 6 or 7 minutes, and I'll show the solution real quick, and then get some refreshments going on. So this one's going to be a little bit JavaScript heavy. So we're going to make sure we look at the HTML on the page and compare it to what's in our browser path. And we want to modify document.title. So this is going to be a place where we write a little JavaScript, we do a little URL encoding, and we do a little copy pasting. Okay. All right. In the interest of getting you to the delightful refreshments outside, because it looks like there's like fruit platters and stuff. It looks really good. We're going to go ahead and call it here and walk through the solution. So we've got this your path here that we're going to manipulate because it does end up in the page source. There's a script tag somewhere here, right? Here we go. Yeah, so we notice that when we mess with your path here, it ends up in this variable. So we need to manipulate what ends up in there. So let's show the solution. So we actually have, I don't even have to encode it. That's exciting. So if you basically, it's almost in a way like the SQL injection. We want to terminate the string. We want to terminate the JavaScript statement with a semicolon. And then, oh, look, here's some other JavaScript. We're going to set document.title and then terminate that. And now, success. Our tab says, please hack my users. And that basically looks like that when it gets, yeah, and let's show the source. Show page source, come here. So now what's happened in the page is we terminated the creation of my var, and now we have some more JavaScript that executes. And then because there was still that leftover double quote and semicolon, we needed one more double quote on the end to wrap that up. So now we've got this just dummy string hanging out here. Any questions about how that worked? So reasons that you might want to do this besides messing with tabs, that's like a really, like, I'm being really obvious about hacking you. Like, but you could go steal somebody's cookies. You could do whatever, right? You could script anything that's on this page. So if you know, like, hey, this is a banking site, and one of the things that you could do is like, oh, JavaScript can go do a funds transfer. Maybe that's a thing you want to script in a way that's nice and silent. So yeah, on key press, you know, give me money. Yeah, question. Yes. So the question was, you would give a user a crafted link to follow that would then cause them to execute that JavaScript in their browser. Yeah, that's exactly what you're doing. Yes, and using that, so using that those credentials on their browser. So if you're this, can kind of rely on if you're signed into a site all the time, like you've got Facebook up all the time in a browser tab, and somebody gives you a malicious URL that will take you to Facebook. Maybe it exploits some vulnerability that it could cause that to happen, right? Yeah.
This could be more automated too, in the sense that maybe I'm on a bulletin board system that is exploitable, and somebody posted a comment that has JavaScript in it. So when I read that comment, my browser executes the JavaScript.
Right, exactly. So the comment was that this could be done in a more automated fashion as well. Like if this gets left on a bulletin board, forum, like your favorite home theater review site or something, or some message board, anybody who comes along hits that and can trigger that JavaScript to happen. Cool. All right, let's have a break real quick. Nominally 20 minutes, but we can get you to lunch sooner if we take a shorter break now. But please enjoy all the fruits and beverages and things outside. They look pretty good. And we'll be back in no less than 20 minutes, or no more than 20 minutes. So 10:40 at the outside. Let's aim for like 10:35. Is that cool? We'll start easing back into things here. One of our attendees was gracious enough to point out to me that the GitHub attack last week, everybody heard it? GitHub got DDoSed. It was like the end of the world again, because the world keeps ending this year. It's terrible. The GitHub DDoS was actually caused by a cross-site scripting vulnerability with Baidu, which is like Chinese Google, right? Is that correct? Yeah. Right. But it was so from the article we were reading up on it about it. So there was like compromised JavaScript that got injected, but it seemed like anybody who had picked up the tracking cookie, like if you were on a site where like if you once you picked up this malicious payload, like anywhere that used Baidu's ad tracking or like Google Analytics equivalent would pick up that payload and drop JavaScript into the page, and you would every second start blasting away at GitHub. So, yeah, how did that get solved? I didn't get. Yeah, okay. So the comment was GitHub was at their mercy. So, yeah, I assume you can start dropping some of that or filtering some of that traffic at some point, but. Okay. Okay. So. Okay. So yeah. So apparently, also linked to the Great Firewall of China replacing JavaScript. You know, you ask for good JavaScript, and you'd get back not good JavaScript that would launch that. Fun times. Yeah. Don't execute JavaScript. JavaScript is bad for you, except when it's not. And Dave, did you had a couple things you wanted to bring up that we were talking about, or do you want to talk about that later? Okay. Yeah, sure.
So I had a couple of example attacks that I did probably 2 years ago against one of the sites of the company I used to work for, and basically they were very simple attacks. We had a contest that we were trying to find the most hacks that you could do against a site so that we can lock them down, and so I was able to do really simple things, like if you went to my domain, and the pages don't exist anymore, but you go to like dstanek.com/clearcart. And so you're on my site, theoretically looking at my pages, you know, for whatever reason, and you don't know that you're clearing the cart of some other site. So it's actually executing stuff on behalf of you on someone else's site. I was able to actually do another attack. I'll talk about it now real quick, but we'll do some CSRF stuff in a couple minutes, where I was able to start adding stuff to the cart. So you can imagine a situation where if I can get stuff into the cart, and then if I could actually order it like a one-click order and change the shipping address, you just go to my site and you're basically just sending me stuff. Like every time you hit the page, I put stuff in your cart and it shows up at my doorstep a week later. Like imagine if Amazon had this problem, right? I don't think that they do, but if they did, imagine what you could actually accomplish. Yes. Yeah. Which, I mean, for most people now, especially like, you know, the average mom at home, right? They're logged into Facebook and Amazon and all these things all the time. So like they just go to a website and all of a sudden they're ordering stuff they had no idea that they ordered.
So you just want to be escaping everything, basically, right? Yeah, and we'll talk about that.
Yeah.
We'll talk about that a little bit. We got one more exercise and sort of a half of one.
I think the CSRF is in a couple of minutes.
Yeah. All right. So the next of our cross-site scripting attacks, we're going to mess with a query string parameter. So this is where we've got some unvalidated user input from a query string that gets included in the page. It's a lot like messing with the path. And let's go to the next thing and see what it's all about. So in this exercise, we're going to add an image into the DOM, like you were talking about, like a little thing that will go and then trigger some functionality. So the source for the image is going to be, we're just going to drop this test image. And bonus points for you if you figure out how to hide it so it's not visible in the page when that happens. And I don't know, what did we want to time box this at? You know, it's like 7-8 minutes. Good enough. Yeah, so we'll do like 7-minute time box on this, and then get to the solution. And again, don't be shy if you've got questions along the way. We love to jump in and try to help out.
Okay, did anyone get this done without cheating? Okay, so fair amount of you. So if you look at the solution below, we actually have the little bit of JavaScript that we're going to put into the page. It looks just like the attack we did for SQL injection, where we want to break apart the existing string, so you can see the first double quote. Then we want to put our code, so the actual creation of the element, putting it inside of the page. We changed the attribute to be display none so that you can't see the image, so the user doesn't even know this happened. And then once we create that element, we put it into the page. And now that made a request to our server that could contain, some of the tracking data, the session ID that we were talking about earlier, that if it was in the cookie, we can steal that and then send it to our server via this GET request. And this is Python code because we actually had to URL escape it so that it would go into the browser okay. And that might have been some of the issue that people were having, is the encoding of like the double quotes and things. The interesting thing to note here is that it's a really simple attack, but I saw a lot of people kind of getting frustrated because you kind of keep trying and keep testing and keep trying. But that's kind of normal for these kinds of attacks, especially when you don't know what's happening on the server side, and there might be some kind of processing where an actual attacker is going to go and think there's a problem because maybe the tool that they use that scans says that there's a problem, and then they go and kind of experiment and then see what the feedback is. And there's just this long back and forth until they get something that actually works for them.
Just wanted to highlight the encoded nasty link that we make.
So, and then feed this through a shortener, no one even knows it's there. We got next.
One last one, but we're really going to only talk through it. So there's one last thing we're going to do with cross-site scripting. We're going to try to break a form field. So this is where you might notice that in some form element, the value attribute gets populated dynamically based on user input. And if you prematurely terminate the value, you might be able to also break out of the tag and inject your own tags, or add something like an on-click or an on-focus or something to that element. We do have an exercise for this, but we discovered something interesting a couple of years ago when we were running this at work and found out that people who had Internet Explorer couldn't do this exercise. So the idea was we were going to steal the user's cookie and write it into a div and do some fun stuff with the inner HTML and do some stuff. Let's see the solution. Okay. So we're going to build this whole query string that says, great, we'll terminate the link, or we'll terminate the attribute, and we'll have a script tag that's going to say, hey, document get element by ID, go give me my cookie, and set its inner HTML to whatever document.cookie is, and then we'll finish up whatever the, finish off the next tag so that we don't have, tag, half-form tag garbage in here. And what we noticed was that Internet Explorer users couldn't do this because Internet Explorer would actually notice that you were trying to do this cross-site scripting, and it would mangle the output of the page source, and it would break and not work. And we said, well, oh my God, I've never seen Internet Explorer do something right before other people did something right. So props to them. Safari and Chrome have picked this up as well. Firefox does it to some degree. I was able to still set an on-click in Firefox, but I couldn't in some of the others.
Firefox can still get something done. It does protect you somewhat against part of the attack, but you can still actually modify elements and stuff in the page, which you can't do in other browsers.
Yeah, so that was fun. But yeah, totally, completely surprised me that IE was okay. So what we'd like to do now is ask a philosophical question while we're here. Can you trust your database? What do you think? All right, lots of shaking heads. No, you cannot trust your database because who knows what lousy data got in there before you fixed all your security problems, because now you don't have any security problems, right? So how do we prevent cross-site scripting attacks? So number one is escape everything. Any untrusted data based on the HTML context that that data is going to be populated into. If you can, use a whitelist for input validation so that you're not accepting just any old string that comes at you, but only particular strings, again, if possible. You may want to consider, if you're not in the Python world, you may want to consider an auto-sanitization library like anti-SAMI that OWASP provides. Please go update your parents' or your in-laws' browsers when you're visiting for the holidays. Like, be a good, responsible tech support person for them. You know, encourage them like, hey, maybe this Internet Explorer 6 is not for you anymore, Mom and Dad. So let's talk about Django in particular. We want to make sure that we're very, very careful with the filters that mark strings as safe or trusted. Try not to use the safe filter or Django utils safe string very much if you can. When you find yourself needing to do this, maybe because you're building some amount of markup in the Python side of it, that's a good sign that you should take a step back and think about whether you really need to do it that way. Similarly, you want to use, like when you're building a form out, you want to use the as P, as table, and as UL when you're displaying the form in a template. They will handle turning the form into markup for you. So the Django form object it'll render the markup for you, and it will do it in a way that protects you against the cross-site scripting attacks. It'll escape all the stuff appropriately. When you are writing your own template tags for Django, the Django utils HTML escape is totally your friend. You want to make sure that this is close by so that you can escape things that go into your custom tag. And it also has friends escape.js, strip tags, and remove tags. So escape will encode ampersands, quotes, and angle brackets. Escape.js will actually hex encode various values for use in JavaScript variables. So if you're trying to populate something that a script tag needs, escape.js is going to be where it's at. If you are writing like a comment form, strip tags and remove tags are things that you're going to want to look at. Strip tags removes all HTML tags across the board from whatever your value is. Remove tags will remove specific tags, but can be configured to allow other tags to pass. So you can say, I want bold and I want italic, but I don't want script and I don't want anchor tags, right? If you are building a Flask site, Flask actually ships Jinja in a way that it auto-escapes in the templates. Don't turn that off. Jinja by itself ships in a way that auto-escaping is disabled and you have to enable it, but the Flask guys have done that for you. So don't disable auto-escaping in Flask. And be very, very careful with anything that you bless with a markup object, a safe filter, or any blocks where you disable auto-escape. So real similar to the caution you need to take when you're flagging stuff in Django as trusted. Any questions before we move on to our next topic? Cool, all right. Insecure direct object references. Do you want to talk about this for a little bit? Or? Sure. All right.
All right, so this one is about actually having URLs, links, or whatever that you're not actually properly validating who's allowed to see and what they're allowed to do with them. So you're exposing some internal knowledge of that actual object to the user, and then you're not going to protect it. Attackers then could go and change the URL. We kind of did this earlier when we changed the URL to go and try to find the settings file. They were able to change cookies, post parameters, other things to kind of find a way to get access to something they're not supposed to have access to. So you can kind of like think of like a Flickr, right, where you have a URL and you get to your image. Well, how do you get to somebody else's image, right? And if they weren't properly protecting those things, maybe you can change some of these data points and get to someone else's data. So compromise is basically all of the data referenced could be taken, stolen. So if it's my data and I find a way to steal your data, I can grab everything that you have that you thought was secret. So think of like a thing that you would use for sensitive-ish data like Evernote or something like that. If you found a way to go and steal someone else's data, maybe that's company secrets or bank account numbers or whatever. And so it's very easy in a lot of cases to enumerate like all the possibilities. So like if you use like a primary key as like the name of the file or some resource, you can find out that it's incrementing just by adding a couple files to your own account. You can just go and enumerate all the possibilities very quickly and go steal everything, right?
All right. So the first exercise we're going to do with this, we are going to manipulate a parameter in the URL to access some data that doesn't belong to us. This one's pretty straightforward, so we'll time box it at about 3 minutes and let it go from there. So have at it. It's been only a minute. Should we let it go longer? Or?
No, that's good.
Okay.
Okay, so this one was a pretty easy one by design. So Mike will go to the URL. So
I'm Fu.
this is a profile, right? It's really simple. So how would you get to somebody else's profile? Well, you just change the number, change the username, whatever the site's doing. And if the site's not properly protecting itself by making sure that only the person who owns a profile can see it, you can obviously get to the next profile. This kind of attack is a little bit less common, right? Just because, especially for profiles, like any software developer, even someone that is brand new to the field, could assume that you want to protect that kind of data. But when you start getting into other things that are not necessarily profile data, it might just slip your mind to validate that someone owns that. Or you might assume that since it's a mangled URL that no one will find it. Scoop. Okay, so how do you prevent this? I mean, simply put, you want to prevent unauthorized access. You put in place access controls that check to make sure that someone is actually authorized to view whatever they're trying to view. Per session, indirect object references, URL design, all that stuff is basically about making sure that you're walking through the process of how someone gets access to something and at what point that you check where they're allowed to view the data, what they're allowed to view, what they can actually do to the data. Because in some cases, it may be data that they're allowed to see but can't actually change. So you need to make sure that you have controls in place that prevent those things.
Yeah, so one of the things about URL design in another presentation I was looking at talked about how, like specifically like per user indirect references were kind of cool. So instead of like, job application 1 2 3 4 5, it could be job application your username dash the date that it was created dash 1 2 3 4 5 or something. So that it makes it an unguessable thing that you can't enumerate the whole namespace very easily.
I mean, also, you've probably seen sites that just go to /profile and that's your profile. Well, that works because that allows them to look at who you're logged in as, and that's the profile that you see. You can't go and just enumerate through the possibilities. Yeah. So Django and Flask basically have kind of the same idea. You want to lock down the views. You're able to specify authorization on each view, so you want to do that. Use permissions architecture in Django or Flask security and Flask login for Flask, and that'll allow you to say that this resource and using the same kind of regular expressions you normally do in Django could be accessed by only the person that owns it or a certain group maybe.
Yeah. So Flask security is, I think, way more comprehensive than Flask login on this topic, so I would probably look at that first. Flask login kind of has restrictions about, oh, you have to be logged in if you want to access this. Flask security goes further and actually has like the role-based access, like the Django permissions architecture. And then the other thing you want to look at that Django makes really easy to do is to limit the query set or customize the query set. So when you're looking up objects, you can restrict the query to only the things that you're allowed to look at. So basically in your models, you have some thingy manager or whatever it is. This is the manager. The model manager is what the model uses to get at its objects when you're using the ORM. And you can jack in your own new model manager to override the default one. And so we can say, great, I've got a manager for my thingies, and I have a special for user method I'm going to add in here, and we'll limit things there for only allowing the query set to contain things that are the user that we pass in. And so then when you are in your update view, you can say, hey, thingy model, I want objects just for this user, and give me the one that comes from the request, as opposed to letting somebody just enumerate through everything. It's kind of a little jumble of different slices from different parts of the application. I hope that's clear enough, but questions are fine too. So. Cool. Any questions about indirect and direct object references? Want to do security misconfiguration? Want me to talk through? I'll talk through the opening. All right. So number 5 is security misconfiguration. And this is basically where there's some kind of insecure application settings or unpatched flaws or unused pages. Like how many people have to go build a thing for your website because your business owner says like, hey, go build me this thing. And then like 6 months later, you don't have that partnership anymore, or you don't, like it's a defunct thing. Maybe it was like a contest that you had to mock up a thing for real quick, and then it's not used anymore. But it hangs out because people like creating things, but nobody wants to take the time to like decommission stuff once it's in production. So unused pages are a good source of security problems because they're still out there and still available. Actually, we had a thing once upon a time with the Backstreet Boys. Like 15 years ago, there was like a Backstreet Boys thing, and we found people trying to attack it like 5 or 6 years later, even after it was down and gone. So it's out there, it's fun. So possible consequences include unauthorized access to system data or some kind of functionality on your application, leading all the way up to a potential for a complete compromise of your system. So that's bad. You shouldn't do that. We're going to do some demos and discussions about this. I think this was stuff you put together, Dave. There's the secret Django debug toolbar and debug enabled in production. So we start with the toolbar. All
right. So is everybody familiar with the debug toolbar? So basically the debug toolbar allows you to watch a request and see exactly what's happening. And it shows you the actual SQL queries. It can show you like memcache lookups. It could show you a lot of data about what's going on within your page. And a lot of people enable this in production because they think, wow, this is great. I can go and, someone's saying that the site is slow. So just add this secret query string that no one else will ever know up into the page, and then I'll magically get all that data. And if you look at some of the things that come out, you get the settings. I think it blanks out the passwords, yeah. But you'll get queries, you'll get file paths, you'll get IP addresses of servers and other things like for memcache that you probably don't want to leak out. Some of those things you find out that they're using debug toolbar, you use the magic setting, and you can use that as the basis of another attack, like a social engineering attack or something else.
Let's see what middleware they've got running.
Yeah, so now you know if they are secure, right? Or what things, like potentially you can attack. They're using the session middleware, and there's a known exploit, an older version of Django, and you can see the version of Django they're running here is that same one. You're able to go and attack them on that. So you definitely want to make sure that as you do these things, you lock them down and it just isn't there hanging out. And I mentioned this earlier, the debug in production. A lot of people, since it's the default on because developers need to debug, a lot of people forget to turn off debug mode in production. So you get a lot of that same data here. And what's even scarier is Django is really awesome in that it shows you the local variables at each step of the frame. So you're able to kind of dip in and see what functions are getting called and what they're getting called with, and some of that is going to be sensitive data or could be sensitive data. So if you can force users into a page like this and capture the data, or if you just want to like try to figure out what the site is doing because you want to attack it in some other way, if debug is on and you can force an error, you can get a lot of interesting data from that.
The good news is they're blanking out the secret key and the password here. So.
But imagine like if you know all this stuff now and you're calling like a huge enterprise company that has offices all over the world, and you say like you call the San Francisco office and you say, hey, I'm in London right now and we're having this big problem and here's the path of the file that we know is broken, and if you have enough information, people will believe you. If you have internal IP addresses and file paths, and you can trick some other developer somewhere else into giving you more information that you can use either to then do a second social engineering attack to get more data or to actually attack the system directly. So it just kind of opens up more attack vectors the more information that you leak.
Okay, so to prevent security misconfigurations, it's really important to have a repeatable hardening process. I stress repeatable so that anytime you have a new server that you're rolling out or something like that, you make sure that it gets locked down. And you periodically want to continue to make sure that if you've got updates and patches, you want to keep on top of that. So you need a process around updates and patches. Make sure you do that periodically. You'd like your architecture for your application to provide secure separation between components. So being good about where the database is and where the application server is, and keeping those things and keeping the users that they run as separated. Yeah, absolutely. And periodic scans and audits are really important as well, especially if you're handling payment data, PCI. You're going to definitely be required to have periodic scans and audits as part of that. I presume HIPAA compliance is a similar kind of a beast if you're dealing with any kind of healthcare data. So, like Django, we've already talked about. Oh, sorry, question. Tools for doing scanning. I know our ops guys really like Hailstorm. The licensing makes it prohibitive for all of us to run individuals. Like, I would love to be able to run stuff against my development environment to find things before it even gets to production or to a staging environment. I know we looked at WebScarab for a little bit, but that was, I forget the reason why we didn't end up.
WebScarab does a lot of the XSS and other things that we've talked about, but I don't think it does things like this, where it's actually dipping down into the system configurations of things. I know that there are certain projects in like Debian and in Ubuntu that you can apt-get installed that actually look through the system, make sure it's installed, checks certain, make sure you're not running Apache as root, and the things that you don't want to do. I can't remember what it's called off the top of my head, but I can get that for you.
All right, cool. So we talked about Django. Don't run debug mode in production. Another really important thing is to keep your secret keys secret. So if you're building a site for that's maybe an open source thing, you put all your source code up on GitHub, don't put your secret key on GitHub. Maybe that should go in your local settings and not out where everybody can get it. There's you can actually go on GitHub and you can search for secret key, and you'll turn up tons and tons of hits. It's really depressing. Did they finally do that? Because a month or so ago, you could still do it's. AWS keys. Oh yeah, AWS keys. There was actually a robot that you could get that would just harvest AWS keys out of GitHub. Yeah. So the comment was it's only on public repos. So yeah, if you've got a private repo, it depends on how much you trust the privacy, right? So if they have some vulnerability that exposes that data, then that's maybe a bummer also. It's a really good idea to keep Python code out of the web server's root. so that if someone is talking to Apache or Nginx and they're going to go get some code, you don't want them to actually be able to dredge up your source code. That's a thing that like some people used to do in the past. Hopefully nobody does that anymore. Back in probably like the CGI days, this was more likely. Yeah. If you can absolutely help it for Django, don't run the admin app publicly. And if you do, don't run it on the same domain as your main application. I think it was Twitter got in trouble for this a couple of years ago, where they had like an admin account that got compromised. And so you like log into twitter.com, and if you're an admin, you can get into the magical admin section, or you could. And surprise, now you're an admin and you can do admin things to Twitter. That was bad. Don't use the built-in Django admin for normal user administrative tasks. So if you have like a business user and their job is to go in and like write blog posts on your Django site, make them an actual blog posting application to use. Don't have them using the main built-in admin, because you'd like those concerns separated. The main built-in admin is just for administering from a developer operational standpoint.
I mean, if you've looked at the Django admin, you can go and just change rows of data. So you don't have to adhere to any business logic at all. You can just go change values. But if you do what Mike said and you create an application that protects the user from making mistakes, and it could go through all the same validation steps the normal front-end data coming in from users goes through, and the business users can use kind of the same process. Because otherwise, you're effectively allowing them to run SQL, and maybe you trust them, but maybe they don't know what they're doing, or they can make a mistake, and it's very hard to recover from those kinds of things.
Cool. So for Flask is a little more DIY for everything. It does not come with that huge admin overhead, which is maybe a good thing from a security standpoint. But you should definitely go read the security docs for Flask. And one thing that's very important for you for production is set app.debug to false, because it also has a pretty rich way of viewing your tracebacks and interacting with them in a debugging kind of way.
So one more quick thing. I wanted to just say...
Yeah, we talked about this too.
Yeah.
Sorry.
Well, even beyond the social engineering, like don't do the DevOps by Stack Overflow, right? Like we talked about separating users and concerns and all that kind of stuff, but one of the big problems that especially startups and other smaller sites come across is that, oh, I need to figure out how to set up Nginx. Well, so you Google it and you find a Stack Overflow post and you basically copy their config and it works. But if you don't understand what it's doing or how to lock that down, like why is it running as root? Because it probably isn't supposed to run as root. Or why is this path wide open? They just serve anything out of this directory is just open to the web. If you don't understand what's going on and what's actually happening there, you can open yourself up to a lot of problems.
On a related note, don't sudo things that you curl.
Don't sudo things that you curl.
Yeah, so if you see like if you see some instructions are like, hey, this is an easy way to go get this thing installed, sudo blah, output of curl of blah. Like, no, that's probably not good. Don't do that. That's not a good process.
Yeah, it's scary because a lot of things actually want you to do that to install their software. You're basically taking a bash script off the internet somewhere and piping it through bash. Question?
Is that a question or? Okay, cool. Sorry.
And then we talked about the social engineering impact of this, because just having that data gives you the credibility to most people, especially in really big companies where people don't know each other face to face.
All right, so number 6 with a bullet, sensitive data exposure. So this is a vulnerability where we failed to properly protect some sensitive data, like a credit card, tax IDs, social security numbers, or your authentication credentials, anything that really, really valuable to a user or to your business. Your sensitive data is really important and deserves extra protection, such as encryption when it's at rest or in transit, as well as special precautions when it's exchanged with the browser. So this was a vulnerability that actually the OWASP folks rolled a couple things up into and renamed it. So one component of this is insecure cryptographic storage. So you're either not encrypting data that's worth encrypting, you're using some unsafe method for generating keys and storing your keys, You're not rotating your keys regularly. Maybe you use weak algorithms or can be forced into using a weaker algorithm than you want. Maybe you have a weak hash or an unsalted hash, Adobe, right? That's not good, right? Then you get all over CNN and you're having a bad day. The other thing that kind of rolls up into this is insufficient transport layer protection. So this is where you might not be authenticating, encrypting, or protecting the confidentiality and integrity of your sensitive network traffic. Again, you might be using like weak algorithms for doing that. Maybe you're using an older SSL that's been shown to be compromised. Maybe you're using expired or invalid certificates. Like that's a bummer, right? You start to train users to click through. Maybe you're using certificates incorrectly. If you don't have a good certificate and people get used to saying, yeah, I accept it anyway, fine, it's whatever. It's got HTTPS in the URL, so it's got to be good, right? Well, no, it's not. It's especially bad if then it expires and somebody else owns your certificate. All right. Man in the middle. Yeah, man in the middle's you. Yeah, question or comment? What's that? Why is it a vulnerability when it expires? So yeah, you want to handle that?
So I mean, that expiring certificates is basically a simple layer of security that allows you to make sure that the person that owns the certificate is actively, repurchasing that certificate, so that you know that if it was compromised or things happen, that they're always getting a new one, right? So like Heartbleed is a great example where theoretically anybody that was using SSL during that time could have been attacked. And if you're not familiar with that, it basically allowed people to read some of the memory. OpenSSL, I think, had a flaw where it allowed people to read some of the memory, which may contain passwords, may not, may contain other stuff, and basically dump it down so that they can go through it and find out if there's passwords or other secrets, including private keys. And it was basically a really, really big open hole.
It was bad.
And so if those things happened, or maybe they happened, that could have been there for like 5 years and only recently did someone notice it. You want to make sure that you're always re-upping the certificate to make sure that you're staying on top of those security practices, your CAs and all the things down the chain are still trusted, because there's and if you're familiar with SSL, there's like a chain of trust where your browser trusts like, I don't know, maybe a dozen or 20 authorities that are allowed to issue certificates, and each one of those, there's a level of trust. And you want to make sure that that level or that trust is always there. So you basically, I think it's yearly is the practice, most people, where they reissue the certs every year. So older certs, different forms of encryption, like we're changing algorithms now to get rid of some of the older broken ones from SSL. So those things kind of fade out and the new stuff comes in.
Some clients may also not handle expired or invalid certificates in very secure ways, right? So you may be like, oh, this awesome SSL certificate expired, I'll downgrade to this other thing that's maybe not, or, right? So hopefully your clients are behaving themselves, but not always. Is there a list of weak algorithms we should avoid? Yes, probably, right? So
An official list, but
yeah. This is a good thing to Google.
Yeah, there's lots of
Yeah.
There's lots of things like MD5 and SHA-1 that are broken. Just people could very easily crack the hashes that you create using those, especially if they're not salted. It's trivial to fire up some machines on AWS and just crack a bunch of passwords.
And then like there was the Poodle this year, right, with SSL v3 that was found to be vulnerable, and so people basically had to just disable SSL v3 all over the place because you could coax it into being downgraded into a easier algorithm to break. So that's not good. So yeah. Is there an authoritative page for that? Probably, I would start looking at OWASP and see what they talk about. So like they advise against like the the SHA-1 and MD5 stuff. They've got a ton of material about different SSL algorithms and things. So I'd start there. It's probably the best. Yeah.
That's the only place I know of.
Yeah.
There's a couple of
Right. Okay. So the comment is Qualsys has an SSL checker, so that's a good thing to use to make sure that your configuration is in good shape. Cool. So let's talk about what can happen. Obviously, compromise of any and all data that should have been encrypted, and this can again be highly sensitive information, personal data, health records, login credentials, credit cards. This can expose individual users' data. It can lead to account theft, possibly compromise an administrative account, like we talked about with Twitter having had that at one point. Poor SSL setup can facilitate phishing and man-in-the-middle attacks as well, which are no good. And there's lots of different attack vectors. So an attacker can monitor your network traffic of your users, maybe in a public place like Starbucks or the conference Wi-Fi here at PyCon. They might actually be inside, like if they're inside your network or like in your back end of stuff, like they can be monitoring that. You're not paranoid if they really are out to get you. There's a lot of examples of sites being hacked to get shell access to machines, and once you're inside the network, you can sniff all kinds of things. Like maybe you're encrypted from the web out to your application servers, but something in your infrastructure is terminating the SSL, and then inside your network, like talking to the database, you're doing it in the clear, or talking to a back-end other system, you're doing that in the clear. Once somebody's in there and monitoring that, they can take all kinds of stuff from you. So prevention, we want to encrypt sensitive data that's at rest, so that's the stuff sitting around in your database. You want to make sure that things are hashed and salted correctly, looking at you, LinkedIn, and Adobe. Like the LinkedIn thing was really bad too, right? We want to make sure that when you've got offsite backups, those should get encrypted as well, and the keys should be managed separately and not stored with the encrypted data, because then whoever gets your backup can get your keys and decrypt your backups. Again, you want to use strong standard algorithms and strong keys, and hash passwords with a strong standard algorithm, and use good salts. And always protect passwords and keys from unauthorized access. Requiring SSL for all sensitive pages is a really good idea. In fact, many sites are now requiring SSL across the board. Kudos to Facebook on this, and some other folks that are moving this way. Google, I think, is moving this way for a lot of stuff. GitHub is moving this way, yeah. Redirect any non-SSL requests to SSL. You want to set the secure flag on any sensitive cookies so that those cookies are only transmitted over an encrypted connection. And again, also we talked a little bit earlier about setting the HTTP only flag, so you keep your cookies away from JavaScript access. Only use strong SSL algorithms. We were talking about this a little bit. The SSL v2 and v3 have problems, so it's time to move on to the TLS and the current versions of that. And you want to ensure that your cert is valid, not expired, not revoked, and matches your domain. So again, you don't want to train your users to accept an invalid certificate. So like you get a little pop-up window that says, hey, this cert is no good. And users say, yeah, it's fine, whatever. Doing that, even in a test environment, trains them to blindly accept things and opens them up to eventually being man-in-the-middle. And like we were talking about with somebody who's monitoring your back-end traffic, SSL, TLS, encrypt all their communications across the wire on the back end too. Do you want to talk about Django and Flask, or do you want me to? All right, cool.
So Django Contrib Auth also has facilities to do the hashing of passwords and proper salting, so you want to make sure you use that. Bcrypt, another library that you can use to actually do some of the actual encryption.
Yeah, they have a bunch of different backends you can use, and so you can choose like the PBK diff stuff, which I think is the default, but you can also enable Bcrypt pretty easily.
There's a lot of choice, which is sometimes bad because you might choose the least secure, but Bcrypt is definitely recommended. And then you want to require your SSL in Apache or Nginx so that you can make sure that your site's secure. And you want to make sure, like Mike alluded to this a little bit earlier, you want to make sure that if your infrastructure uses an SSL terminator at the edge, like say your load balancer does the termination, that you secure any sensitive traffic within your network as well, right? So just because the user to the website is secure and their data won't get stolen there, it doesn't mean that someone can't somehow get into the back end of the system and watch that same data going back and forth. It's a little bit harder to do, but it's still entirely possible.
For performance reasons, you're better off if you can do it in Apache or Nginx, but there's also Django middleware that can help you out. So there's a couple of different older solutions like Django SSLify, but brand new that just landed in Django 1.8, they incorporated a bunch of things from the Django security sub-project or side project, and there's a new Django security middleware that lets you easily configure all kinds of things about how do you enforce, like I only want SSL and this is how I want to do it. Yeah. The question was about impact on performance. Basically, Apache or Nginx is going to be doing that a lot faster than you're going to be able to do it in Python. And then you also don't even, like if you're doing that at the Apache or Nginx level, you're doing that redirect there, you're not going to even incur any of the overhead of having that request passed off into the Python layer and having your Python stack have to go through all kinds of hurdles and hit the middleware and execute that stuff. So if you're concerned about the overhead of that, processing in Python that you don't have to do, then do it up higher up before you even get the request handed to you. Does that address it? Yeah. So in terms of, so in this case, this is about saying like, hi, I'm a Python website, but I should only ever be accessed over HTTPS. You should never send me something over HTTP. Go issue this redirect and get out of here. So you want to be doing that up the stack. This isn't necessarily like down in the Django layer. You're already going to have your SSL terminated. You'll be you have to have that data already. It's not doing the decryption there.
Yeah, so I mean, if you're trying to choose the algorithm based on performance, it's not going to matter. There's going to be a millisecond here or there, maybe, but yeah, like you were saying, the actual performance is so good, especially if you're using a C-based terminator, like Nginx or Apache, as opposed to Python, that you're not going to notice the overhead. If you were doing it in Python, you may, because each request will have to do a lot of extra work, and Python is a lot slower to do that kind of work than it is to just let the web server do it.
Yeah, like 10, 15 years ago, it might have been an okay excuse that like, oh my gosh, my web server can't take all this SSL that it's got to decrypt. But we have modern hardware now, and like you were saying in your comments, sir, that the performance impact of having SSL at the web server now is negligible. So you might as well just encrypt everything. And that's actually going to be a lot easier coming this summer, and I wish I remembered the link for it now. Mozilla, I think, is working on a tool to make it really easy to get good, valid certs, install them properly, secure everything by default, automate your updates and things and stuff, and it's really cool. And they're going to be doing the certs for free. And I cannot remember the name of the URL right now, so I'll have to look that up later and be really embarrassed. Oh, yeah, I got to... Let'sencrypt.org. Thank you. I appreciate that. By our powers combined. Yeah.
So the question is basically if you have, and correct me if I'm wrong, if you have a load balancer that's sitting on the edge and it's dispatching to Python processes, should you also have, say, a local Nginx that the load balancer talks to that talks to the application? And so there's the extra hops that can secure both ends. That's a really good question. It depends on what you're, so there's a lot of things, right? There's performance, because now you have to deal with a couple extra hops along the way. And if your end load balancer is already doing it, should you keep it like that? I would say probably not, because I would tend to be on the more secure side and let the endpoints themselves actually do the termination. But if you had to have your end do the termination, so say your load balancer does the termination and it has to be that way, some operational requirement or whatever, I would probably have that in between secured as well. So you'd have a local Nginx that would proxy over to Python. So you'd be SSL from user to website, or to user to load balancer, then load balancer to web server, and then realistically web server to database, web server to anything should also be encrypted. And that's kind of hard to do in a lot of cases for things like Memcache and Redis, where by default you don't have that capability. You have to kind of roll your own crypto.
So a couple things you can do to Django. Go in your settings, set the session cookie secure true. That'll set the HTTPS only flag on the cookie for the session. And you can also set the CSRF cookie secure. Now that means your sessions and your forms will only work on HTTPS URLs. You can't do them on plain old HTTP anymore. But that's perfect if you are going to 100% HTTPS for your app, which is a reasonable thing to do at this point. In Flask, you want to make sure that you salt your passwords. You can use Werkzeug security. And there's an example out here. Don't scramble to write down URLs, because the slides are up online and you can get them later, so don't panic about that. But the Werkzeug security has facilities for salting the passwords using good algorithms. There are a couple of different solutions for requiring SSL. There's the Flask SSLify, and there's also a thing that Jacob Kaplan-Moss wrote in Anger a couple weeks back called WSGI SSLify, which is WSGI middleware that will allow you to basically anything that talks WSGI, you can say, no, you're going to go to SSL, and I don't care. That's it. You're done. But like, so across the board for like anybody who's using a WSGI app, you can use that. It's pretty new, so it's worth taking a poke at and making sure it's in good shape, but it seems to get the job done, which is nice. Also, you can use bcrypt again, which is a really good idea. There's I think you use passlib to plug that stuff in to the way that they do Flask security. Like Flask security like rolls in passlib.
Yep, I think so. So passlib, I just want to say a little extra thing about passlib, because it's extremely useful for stuff just outside of Flask and Django. If you want to secure hashing algorithms and stuff like that, the hardest part of doing any crypto is not the algorithm itself, because you normally don't write your own, blowfish algorithm. The hardest part is normally the process of doing the encryption, where you store the keys, where you do, if you're talking about hashing, where you do the rounds, how many rounds you do, and how that stuff works out. And passlib allows you to not have to worry about a lot of those things. So like when you hash something, you might hash it once and think it's good. But I think the OWASP recommendation is 1,000 rounds? Or some, yeah. There's some number of rounds that it says that you're supposed to hash and rehash so that it's secure. And passlib does a lot of that stuff for you by default. So that it not only does it record the number of rounds that it did, so you can vary rounds between requests, but you can vary the hashes. So it makes it really difficult to get a whole list of hashes and break them all. All right, you might be able to break one, but it would be very difficult to move on and break another one. Yes. So like in the really simple case, that you MD5'd everything, right?
And what was the question?
Sorry, the question was, is the number of rounds, how does that make it secure essentially? And so effectively, when you do like a single round of MD5 and you have some kind of salt, and it's just a single salt used for everything, you could start using pattern analysis to figure out what that salt was, and now you broke everything, right? It's very easy to do. So one of the recommendations is you vary the salt, because now if you can break one, then it's not any easier to break the next one. So you still have to have the same amount of work. Rounds is kind of effectively the same thing. If you hash and then rehash and then hash again, it's very hard to come up with patterns for what's actually going on in that data. So if you have 1 million hashes and you can find a pattern, you can decode them all. If you don't have a pattern, then you have to do each one individually. And if it takes 1 year to do each one and you have 1 million of them, that's a really long time to get to the end of the data. But if it takes 1 year to just uncover the secret, now you have 1 year of work, or one machine year. So that could be like 10,000 servers in a cloud somewhere running that stuff in 15 minutes. But now you have everything. Right? So the number of rounds and the variety of the salt that you use kind of helps protect against that pattern analysis.
Yeah, so if you're varying the number of rounds, then the attacker isn't going to know, well, do I do this 1,000 times? Do I do it 1,500 times? Do I do it 1,001 times? How many times do I actually need to rehash that to break that hash?
Yeah, well, so basically, if you look at the actual outcome of PassLib, you have effectively the rounds themselves are actually encoded inside of the string. So it knows the number of rounds, but you can't, just because you have that and you say you do 1,000 rounds, that means you have to do the algorithm at least 1,000 times to figure out if you are correct. And if you have to try it 100,000 times, to get to the right hash, then you have to do 100,000 times 1,000, and then it just exponentially gets bigger and bigger. It knows, I can't remember exactly what parameters it knows. I think it knows the algorithm it used, so like SHA-1 is encoded there. It knows the number of rounds, and then it has the actual data, and it's like separated by colons or something like that.
All right, I think that's it for this one. Ready to move on to number 7? All right, number 7, missing function level access control. This is a great developer screw up. I'm guilty of having done this at least once, where the application does not protect its functions properly. This can be a result of misconfiguration, or you forgot proper code checks, and somebody didn't catch it in a code review, probably. Code reviews are good, by the way. You should do them. So attack vectors for this kind of thing. An authorized user changes the URL or some parameter to the URL of a privileged function, or an anonymous user could access private functions that aren't protected. You can also get at this by doctoring cookies. If you're able to tamper with the cookies, that may be a vector for escalating your privileges. And it's important to keep in mind that just because you don't publish a URL somewhere or a link to a URL somewhere, that doesn't mean that people won't eventually find it. There is no security by obscurity anymore. So this may lead to compromised user accounts, compromised administrative accounts, or the really fun-sounding unauthorized use of privileged functionality. So we're going to do an exercise, and this one is pretty lightweight, no fancy JavaScript encoding here. We're going to manipulate a URL to access privileged functionality, and we'll give it a couple minutes and see where we were at. Sensitive data exposure. Oh, yeah. Yeah, we didn't do a sensitive data exposure thing, did we? No. That's because you can't sniff your traffic when you're talking to localhost, because there's no traffic to sniff. All right, so we'll do this one and give it a couple minutes. How's everybody doing with this? It's pretty easy. So let's say something in the cookie is like a flag that indicates what kind of user you are. Admin equals 1, admin equals 0, right? Or user type equals 1, 2, 3, whatever. Like packed in the cookie somewhere, encoded in the cookie. If that cookie's not signed, you as a bad person can go like say, oh look, I've got this cookie and I'm going to change this, you know, flip a couple bits, and I'm going to use that in all my requests going forward. You could manipulate it in the browser. You can manipulate it outside of the browser and play it back in and change the cookies using JavaScript. Once you're, you know, if you're on, you know, example.com, you can go into your debug toolbar. Oh, did my phone just kill itself? That's cool. I've never seen it do that before. Cliff dive. That's neat. Yeah, so you could go into the browser and go modify document.cookie, and as long as you're just on that page, now you've changed the cookies for that site. There's browser plugins too that allow you to edit the cookies before a page request. Yeah. So look at them, and if you see it is admin equals 0, and then what happens if it's equal 1? Yep. Then it's not signed like I said. Yeah, so this is why it's a bad idea to let JavaScript ever touch your cookies. So we've got this kind of flaw. Here's our happy little page. Oh, it's got a happy action. I wonder what other things it might have that you might do with it. Oh, it's a super secret admin interface. I hope no hackers get in here. Gosh darn it. So yeah, like we were talking about, cookies can also be used. This is like, you wouldn't think people would do this, but this is like mind-blowing. Like it's really easy, and it's really easy to screw it up. And it happens. It's very depressing. So how do we prevent against this? We need to consider every single page that's in every single endpoint of our application, and we need to ask, is this thing public or private? And if you need authentication to get to it, we need to make sure that you've actually, you know, checked that check is in place. You need to verify that. And if there's additional authorization required, not just authentication, you know, hi, I'm a user. You need to say, you know, hey, I'm user 123, I get to have access to user 123's things, or hey, I'm in a role that says, yes, I'm allowed to do the admin things. Verify that those checks are in place as well. A really good policy is to deny all by default. It's not just, you know, what your sysadmins tell you when you ask them to do things for you. It's also good practice for development. So deny all by default, and then explicitly grant access only to particular users or roles. Specifically to Django and Flask, you want to lock down your views using Django's permissions architecture, or Flask security has a role-based system as well that you can incorporate. And again, don't use the Django built-in admin for doing your day-to-day user tasks. You want to talk about number 8? Should we talk, any questions while we're here before we move on? This is a pretty straightforward one, I think.
It's very similar to the ones previously. Okay, cross-site request forgery, so commonly known as CSRF. This is basically when you're attacking a site through another user. You're tricking that user into doing something malicious or whatever on their behalf, and they don't really know that it's happening. So my example earlier that I gave where I was able to add something to a cart if you went to the one website that I created, that was basically just tricking the user into doing something that ran some JavaScript that they didn't know existed that did something on their behalf somewhere else. Right? And it's really hard to detect those things if you're a user, because things are just happening under the hood. You expect scripts to run, and nowadays where we have tracking things all over the place, you expect to get JavaScript from js.whatever.com, and you don't really know that, hey, that's not really part of the site that I'm accessing, right? So you don't really have visibility into that stuff. So a lot of different attack vectors, image tags, XSS issues on sites, fake buttons and phishing forms. So like you can imagine going to or getting one of those emails and say, hey, you need to log into your PayPal account because we were compromised. You need to change your password. And that's not PayPal, that button goes to a site that gives you forms and other stuff, and they're actually then going to take your data and give it to PayPal or eBay or there's
whoever they're spoofing.
whoever they're spoofing, one of those sites that have had this issue in the past, and actually do stuff on your behalf. You think you're going and doing one thing, but they're actually taking that data and doing something completely different. So you can change basically any data as that user, right? It's the same kind of a issue that you have with some of the other attacks, where if you're basically telling the user to do it for you, take your data out of your bank account and send it into my bank account. So now I just took $1,000 from you and put it into my account. They're doing that for you. You're just effectively telling them what to do. You can do basically anything that the site could do if they're not protecting against it as that user. So, just imagine the kind of havoc you could wreak on somebody. Talk about the example.
Yeah, so just a couple of real-world examples. Facebook paid a $5,000 bounty for someone that found and responsibly reported a CSRF attack that's described in that link. And then Gmail has a CSRF vulnerability. I'm not sure, do they still have it? We could find out. Yeah, so this will actually cause you to log out of Gmail, and it's a nuisance, but it's bad form for somebody that's that prominent in the internet to have something that's got this kind of simple vulnerability in it.
I think you want to go to the URL and read it because it's kind of interesting. I think it's an image tag or something really simple that if you just put it on your own website, you would effectively log that person out of Gmail when they hit your website. You can't really do anything with the data. I think right now they've determined you can only log out and force someone to log out, but it's still scary that you could do anything on that user's behalf.
All right, so let's get to some exercises, shall we? So we're going to craft an image link that triggers some functionality on our site. This is something you can also do in an iframe if a GET request works against the site. And we're going to let's budget about 10 minutes for this. Because this one's a little involved. All right, in the interest of time and making sure we get everybody to lunch in a little bit, because that's coming up, we're going to cap it here and talk through the solution. So a lot like the cross-site scripting exploit we did before, we fired up an interactive Python shell, imported URL lib, because it's great for sort of the Swiss Army knife of doing some things here. Grabbed our URL that we want to use. So we're going to send things to csurf gift card, email it to evildoers.com for an amount of $100, and inject that into this JavaScript that's going to create an image and add it to the page. It'll do the document body append child, and then we'll quote the formatted version, and that builds us a link. And so in this example, we've combined this with the cross-site scripting so that the domain on the link is something that's familiar to you as the user, so that it's going to be something that you want to have. And hooray, we've successfully padded our pockets on the backs of others. So this link looks like this big encoded blah, 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 all this stuff that we did to make it URL safe. That is, so in our URLs, we've sectioned off each exercise. So this is the csurf set of exercises, so that's just logically, that's how we've grouped things. Does that make sense? So, I mean, it's just, how does this get executed on some other site? So we have, so we're making as if it's a fake quote unquote image, right? So so you might place this image on a site that lets you paste image links like in a comment form or something. Pretty much anywhere that you might want to have a user go. It could be in like an email even, or yeah.
Like this is effectively posting the form without posting the form. This is actually doing it as part of a GET request. So I'm hoping that
it's like a drive-by kind of.
Yeah. So like normally when you get data like this, you want to make sure that it's a post and it can't be done via GET because of things like this. But effectively, we're just allowing the form to. So in Django, you can pull out a GET, you can pull out a post, or you can pull out of the other one that's like all of them.
Yeah, params.
Params, right? And if you do that, you don't know if it's a get var or a post var. So you want to make sure that if you're expecting it to be a post var, you check that it's a post var, and then this won't work. But that's effectively all we're doing is we're making a post request that's formatted as a get request against a different site.
Right. So in the interest of time, we're going to kind of gloss over this example, this next exercise. So this is a case where instead of having an image that gets posted and you get like a drive-by attack, this is a place where we're going to have a third-party site that looks okay and offers you something enticing, like I want to click this button to see some kitten photos, like show me the hilarious kittens right now. And instead, actually ends up posting a form to our vulnerable site that is going to cause this gift card to get sent. And like I said, in the interest of time, we're going to just cheat and we're going to look at the solutions for that real quick. So that is cross-site from a forgery from a third-party site. So what we would do is we would go into our malicious page that's masquerading as a good page, and we would create this form. Same kind of thing. So in this case, they've locked it down so they can't do a drive-by get on it, but it's still going to accept our post. And we'll set up that, here's our hidden variables that are going to make sure that we get money transferred to us, but we're going to disguise it as viewing cute kitten photos. And so then just triggering that will cause it to do that. And you could also have hook JavaScript up on this that is going to make sure the post happens, as well as then like directing you somewhere that you want to be legitimately.
Yeah. So like if you visualize this as two different sites, you're on kittenphotos.com, you get this form that's hidden that has that view photos button. And then you have the attacked site like mybank.com. So this would actually live on one site but send the post completely somewhere else. And you can also have JavaScript that auto posts these things. So like you can have it say on load. If there's a form that says, you know, ID of hacked, post it. And the user will never see that stuff happening. It'll just automatically happen under the hood.
So I'm going to keep moving on so we get to lunch on time because that lunch is delicious. So we talked about CSRF via a form post here. So to prevent these things, these types of attacks, don't do things on a get. A get should just get you data and not change state anywhere. A very common strategy for preventing CSRF is to include a unique token in a hidden field. It's often used in concert with a cookie that gets set on you so that if the token in the cookie and the token in the form don't match up, we know that they weren't sent together by the same person. And you want to validate that token to make sure the request is from on-site. And obviously, avoid putting that token into the query string where it's going to show up in logs or in browser history and stuff like that. So some specific Django advice: don't change the built-in settings. Django comes with CSRF protection enabled by default. Do use the existing CSRF middleware that's there for you, and there's a CSRF token tag that you put in your form templates. Use those. Be very, very, very careful about deactivating it using that CSRF exempt decorator. That's a place where you need to step back and say, like, why am I doing this? And you want to be careful about your APIs as well, like TastyPie or some of the OAuth stuff. There are examples for how to do CSRF protection with that, and we just don't have the time to get into it here. But like TastyPie puts a CSRF exempt decorator on all of its API calls by default, so that's entertaining. Yeah. In Flask, there are various solutions for CSRF. There's sort of a DIY solution that's in a snippet that some people have accused of being a little too naive. So you may want to look at something like Flask CSRF or Flask CSRF for CSRF prevention, as well as the Flask WTF for doing your forms has a token and cookie-based solution for you that's real similar to Django's. In fact, the Flask CSRF is a direct port of Django's CSRF middleware. Not as much as you'd like. Yeah. Right. So it depends on, so like this differs a little bit from like the same origin policy, right? So your JavaScript engine is going to try to lock you down to some degree about what you can or can't access from different domains if you're doing things in JavaScript. But this could just be like, hey, I'm supposed to render this image. I'm going to go fetch this URL, and that's all that it takes to do like, as long as your browser will do a get for it, like, you're done.
I haven't found a browser that actually protects you against the post either. If you just put a form on your page, it'll allow you to submit the post to a different site. Hopefully this will be better. So the problem is that, like, we have a culture of allowing these things because of the way like tracking pixels and a lot of those other things work that we just take for, not take for granted, but I don't think anybody likes them. But that's just the way that things work in the internet right now, is that you'll get JavaScript from this domain, you're going to get an image from that domain, and the users don't know or don't have to care.
All right, 2 more to go, and then we'll wrap up 7 minutes. All right, we can do this. So number 9 is using known vulnerable components. So libraries and frameworks and other modules that you have installed almost always run with full privilege in your application, and it's really hard to stay up to date on everything. So a question you have to ask yourself is, do you even know all the components you use, let alone the versions of those components? Like, and it's not just in your Python stack, it's everything. What's your web server? What's the OpenSSL? What's the OS? What's all of it? So components with known problems can be easily identified and then exploited with automated tools, which is why this is bad news. So an attacker can identify one of those components through scanning or some kind of manual analysis and then will tailor an exploit as needed. And this is actually an attack that's more difficult the deeper in your stack the component is, but it's still something to be concerned about. So the full range of weaknesses are possible, from something that could be really minimal to complete host takeover and data compromise and the end of the world. It's been a really good year for vulnerabilities that have logos, so we're going to go through some of those now. So Heartbleed was a really critical flaw in OpenSSL that landed right about the same time that I did in Montreal last year. There's no coincidence there, just as a thing. But many major sites had this OpenSSL flaw where they were leaking user credentials, and so you could ask for like, hey, give me a little bit more data than you're normally going to give me, and eventually you could piece together like people's usernames and passwords and stuff that were in memory. Terrible. So make sure your OpenSSL is patched. Shell shock was fun. This was a flaw in Bash that allows an attacker's code to be executed as soon as the shell is invoked. So you can have things that get injected into the environment, and as the request gets handed off, like everything goes straight to hell. We talked a little bit earlier about Poodle. It has a cute logo also. So this was a flaw in the encryption scheme of SSL v3. The response to that has been to turn off SSL v3 everywhere. So if you're still running SSL v3, don't. Ghost was kind of fun. This was a vulnerability in glibc in the get host by name functions for DNS resolution. You could have like complete remote compromise of a target system with no knowledge at all of the credentials involved. And the proof of concept actually used an email message to get a remote shell on another box. Like, scary. And this one is not so much a component that might be in your stack, but it might be worth talking about. It's a fun thing that surprised the heck out of me this year. Superfish. Lenovo pre-installed this malware that allowed man-in-the-middle attacks so that they could inject ads into web pages for you, but it also left you open to man-in-the-middle attacks for everything else. So that's nightmarish. And think about how like somebody could then use that to gain access into your systems and knowledge about your application as well, and get that leverage. So don't use components you don't write. Okay, not realistic. Okay, so keep your components that you don't write, keep them up to date. You should identify everything you have and what version it is. And you should keep your eye out and monitor the security of those components. Okay, well, how do you do that? Because that's easier said than done. A couple pieces of advice. You can actually use pip to find your old Python packages. You can pip list -- outdated, and it will tell you what things you have in your requirements file that aren't current. It's pretty neat. Another thing you can do is you can use a service called requires.io, which I really like. You feed them your requirements file. You can either point it at your requirements like out on GitHub, or for like a nominal, I think it's like $15 a month, you get access to their API. And you can like if you don't want to have your stuff out in the public where they can read it, you can push to their API just your requirements file, and they'll keep an eye on things and do alerting for you and contact you when there's vulnerabilities or problems. For Django and Flask, you want to keep an eye on mailing lists. There's the Django announce list, and Flask has its own mailing list. Also follow Django Project on Twitter. They're really good about publishing their security updates and things. And when Django has a security update, or Flask has a security update, go fix it, go patch it. That's important.
And then for the outside components, like your web server, your operating system, each one of those things typically has a security list that you want to pay attention to. So if you're running Debian and you're running Apache, you want to make sure that you're watching those security lists to see if any issues come across. And they'll tell you when you need to upgrade, what the potential impact is, because sometimes it will impact you, and other times you can delay the upgrade for whatever reason because it doesn't actually impact you. But you have to actually watch for all those things.
Yep. All right. Last one. Last one. Exciting. Okay, so unvalid redirects and forwards. You can abuse redirects to trick a user into visiting some URL that redirects or forwards the request without validating where it's going to. And the users are prone to click on this because the link is to like a legitimate site that they really want to go to. And you can use that to install malware on them, fish for information from them, or bypass access controls that they might have on the site. Maybe you can route around that point of access control. So we were going to do an exercise where we use URL redirection to do this. Let's just walk through it real fast because we want to get to lunch. So we've got a page. So it's common practice in a lot of places to have a page or a URL that redirects to someplace else based on a query string. It might be like a login page that has to go back to somewhere that it came from and needs to know where to go. It might be something to gently redirect you from HTTPS back to HTTP without your browser saying, hey, you're being redirected to a non-secure location. But if you don't check what that location is, it's a good way to hijack stuff. Let us see that. So we have this link that doesn't really do a whole lot yet. Let's copy the link, paste it in here. And so we can change the URL, and let's send it to how about I actually don't screw up my URL? How's that sound? All right, so that could be to anywhere, right? That could be to a phishing site or something that looks like the site I want to be on. It could be, a link that's in an email that looks well crafted. So generally don't want to do that or allow that.
And also, if you think about it, that original link could have been to some site you wanted to go to that'll redirect you to a site that maybe looks like it but is malicious. So the link itself, when you look at it, everybody tells you look at the domain and make sure that it's where it's supposed to go. If it was a Twitter link, it should be twitter.com, whatever. But if they send you to somewhere else that kind of looks like Twitter because of that refer or redirect, then you might not know the difference.
And it could redirect back to where you wanted to go in the first place anyway, once you're done getting phished or malwared or whatever.
Yeah, exactly.
So then the other thing that that is in this section are forwards. And this is a lot like the thing that we saw earlier with the super secret admin area. So we have, a forward is where you're redirecting to a different callable thing underneath in your application. So instead of doing an external redirection that says, hey browser, 301 or 302 go over here, you're saying, that's great, I'm just going to hand off to this other piece of code to process your request. So in this case, we're forwarding to our little happy function, and instead we might want to forward to an admin function, right? And if you let that happen in the query string, that's no good. Don't do that. So don't use redirects or forwards if you can. If you do, don't involve user-supplied data to build the redirect location. And you want to ensure that the supplied value, if you do have to do this, you make sure that's valid and is authorized for the user. Django has a thing called utils HTTP is safe URL to check redirect URLs. That's worthwhile to use, though they do keep fixing security problems with it. So stay on top of your Django updates. But this is a tool that's used by Django Contrib Auth internally. So they'll be checking automatically to make sure that, hey, when you're going to log in or you're going to register, when you get done doing that and it redirects you back to where you came from, you're actually still on the same site and not going off to somewhere else. You may also want to consider wrapping that is safe URL call if you have to allow for other off-domain URLs. So if you're doing a redirect manually. So like in your code, you might have a view that says, hey, if this is a safe URL, then go ahead and return a redirect with that URL. So you may instead want to say, hey, is this a whitelisted URL? Maybe I've got to go to multiple hosts that I allow because I've got subdomains or things. So this is safe URL. I don't believe considers subdomains to be equivalent. So you might set up a whitelist with this example. Again, you don't have to stress about copying stuff down because it's in the slides. And you can check, hey, for every host that you might consider whitelisted, is the host that we're going to safe? And then hey, we can go to us.pycon.org or pycon.org. Let's allow both of those and check that. Flask has a snippet about doing redirection back. You can also, there's another snippet that shows how to redirect back to where you're going, but more selectively using a whitelist. And they actually even cookie the previous URL so that you get around some of the CSRF stuff. And you can also modify these approaches to suit, as with the Django example. So like if you have multiple domains you need to check, you can do that. Okay, so that gets us to the end of 10 different types of vulnerability. That's exciting, right?
Is everybody feeling safe?
Yeah, so who out here has vulnerable apps? Yeah, probably, yeah. So, yeah, one of the most reassuring things that I've heard come out of this talk, though, is a couple years ago at PyCon we ran it, and somebody tweeted at me at lunchtime saying that they'd identified something that they had and like fixed it while they were at lunch at PyCon, and that really warmed my heart that we made the world like at least that much safer. Yeah, so a few parting thoughts before we go. Number one, think like a bad guy. Your business owner gets the privilege of thinking like a user and thinking like a business owner. You don't have that privilege. You also have to think of every single thing on your application the way an attacker might, and think about how an attacker might leverage that functionality that you're implementing in order to gain an advantage over you or to exploit your system. The next thing to remember is that you should not stop at 10 vulnerabilities. Just because we did the OWASP top 10, and these are the most prevalent things, there's still a whole lot more vulnerabilities out there on the web that you need to be aware of and think about. But this is a good starting place, but use this as the stepping stone to then build in an even better process for yourself. You have to accept the reality of constant change. This stuff comes up all the time. There's things going on. There's new DDoS attacks. There's new OpenSSL vulnerabilities, it seems like, every day or every week. Like, stuff's going crazy all the time, and you've got to stay on top of it. But you also need to think positive. With a sane process and a little courage and a good attitude about this, you can end up making your application a really safe, secure thing, and have this journey that you go on about making a secure application and maintaining a secure application and staying on top of it with good processes. And as you do that, you end up making a better situation for your company. You make a better situation for yourself as well, because these are valuable skills out there in the world now. So, but think positive. You can do it. You can make the world better with this. Just to recap announcements, feedback is via the Guidebook app this year. There's a whole lot of volunteer opportunities to help enrich your PyCon experience, as well as lunch will enrich your PyCon experience. That's upstairs in room 710. Whole lot of links that you might want later. If you grabbed the repo earlier, it has a link to the slides, and I'll publish an update to that probably this afternoon. But it's out there, and the link will still be the same, so you can just click through from the slides section in the bottom of the README. If you'd like to contact us later, you can find me on Twitter at mpirnat, or my blog that I don't update nearly as much as I used to, at mike.pirnat.com.
You can see my contact info. Tracespec.org is my blog, which I also do not update very much. And I would love to have you guys go back, start attacking your own apps to try to figure out what you can make better, and then let us know. I'd love to hear that you found issues and you were able to fix them very easily.
Yep. All right, with that, I think we'll wrap it up and everybody have a great day. Have fun at lunch and tutorials this afternoon, and an excellent PyCon to everyone.